Good morning, everybody. Thank you for attending this third FF4EuroHPC workshop, aiming to present the outcomes of the projects selected during the first FF4EuroHPC Open Call. So today's workshop includes experiments related to weather forecast, pollution, and counterfeit detection sectors. Here we have the agenda of the workshop. So after the welcome, you will have a short introduction of the FF4EuroHPC project by my colleague Tina. Then we have a first presentation on high performance computing for high value weather forecast by Jose Munoz from Aslogic. The second presentation will be done by Emanuele Della Volpe on HPC-based navigation system for marine litter hunting. And the last presentation on market innovation sourcing and will be done by Martin Shade from PriceIntelligence. And we will finish the workshop with some conclusions. Now you will have session of 5-minute questions. Question and answers after each presentation. Please shake your hand or ask, put the question on the chat or on the question section. Now I let the floor to my colleague Tina to present, to introduce FF4EuroHPC project.
So welcome to our third workshop. My name is Tina Marz. I'm a project manager at Arthur and also FF4EuroHPC communication lead. And my task today is to give a really brief introduction to the project and give a little bit of context to our success stories that will be presented in the next hours. So FF4EuroHPC is H2020 research project. It is coordinated by HLRS and participated or contributed by 5 other partners, which are Arctur, SESGA, Cineca, Scapos, and TerraTech. So the project itself actually contributes to diverse EuroHPC objectives, but our main goal is to increase the innovation potential of SMEs by promoting the use of HPC and other advanced technologies for their business. Then we are also linking the SMEs with NCC, so National Competence Centers and Digital Innovation Hubs, which actually provide SMEs access to the HPC infrastructures or serve them somehow with the knowledge or further consulting. We also provide the success stories, which will be also presented later. And through promoting the use of HPC in business and highlighting the incomes of these experiments, we are fostering the wider innovation in the European industry sectors. And lastly, we are also providing an effective mechanism through the open calls and supports to our experiment partners, and thus actually support the SMEs in lowering their barriers so they can access to the market and exploit new business opportunities easier than otherwise. So within the project, 2 open calls were offered and were targeting actually the highest quality SMEs, which have innovative ideas that could be solved by HPC AI, machine learning, HPDA, and some other related technologies. In total, 42 experiments were selected through the review process and are actually supported by funding, which includes 132 partners from 22 EuroHPC member states. So on the map, you can see the dark colored countries, which are actually parts of this project, and we are really happy to have this wide geographical spread covered. 62 of partners are 62% of all partners are SMEs. And we are mainly focusing on manufacturing sector, which covers 57% of all experiments. But we are also covering other sectors such as energy, automotive, health, and some other sectors. Just giving a brief introduction to the experiment. So experiments are actually use cases on which experiment partners are collaborating and trying to use the technologies to solve some business problem of end user. In experiment, actually, we have a collaboration of end user, which is SME. Then we have also collaboration with other partners, such as HPC providers, domain or technology experts, ISVs, or some other domain experts. And as soon as experiment is successfully concluded, then it's resulting in a success story which highlights the business benefits and actually inspire the industrial community. And this is our task today, to introduce you three, I would say, brand new success stories, which were as a result of the first open call. So far we have 16 new success stories, but 26 experiments from the open call 2 are still running. So I would kindly invite to visit the website. So link is also provided here. And then you can find all experiments and descriptions, so you can find ideas on what we are collaborating. And further, you can also find the information on the success stories, HPC-related events, and other HPC-related content on our project website, social media. So you're kindly invited to get the inspiration on how to use HPC for business. So this was actually the presentation from my side, and I would like to leave the floor to the free success story presentation, and thank you very much for your attention.
Okay, well, so good morning, everyone. My name is Jose Luis Munoz. I am the project coordinator of HERCULES. HERCULES is the acronym of High Performance Computing for High Value Weather Forecast, and we were part of the first call of FF4. Oh. Okay, so in order to clearly state our project, I have divided my presentation. Well, first I will introduce the problem, I will go for the solution, then I will present the consortium, why are we using high performance computing, our main achievements, and for sure all the challenges and next step that we need to face. Okay, so let's start with the problem. So nowadays, manned aviation relies on local weather information provided by national agencies in order to plan their flights, in order to go from point A to point B, from Madrid to Copenhagen in this case. Well, this information is quite important as the safety of the flight and some economical points of the flight, like for example, fuel consumption, depend on the weather. So nowadays, national agencies are providing this information. Here you can see that the live information was updated in Madrid 70 minutes ago, and the forecast was made 3 hours ago. So the question that we raise is, how are we going to work when we will have this new aerial vehicles that now we can see, well, all around the news, right? They are going to be, well, in the way that they plan and they execute the mission, there are big important differences. So they don't have origin destination are not fixed. So we cannot rely on the expensive ground infrastructure that we have in our airports. We are not going to have air traffic controllers. We need a higher spatial resolution, horizontal and vertically, and weather forecasts need to be updated more frequently. Well, so every time that I have to talk about these new area vehicles, I know that it looks like science fiction, and in fact, it was von Friedland in 1927 in his film Metropolis that showed it for the first time, you know, these airplanes for these area vehicles flying inside a city. But in the last year, it has become a reality. So I'm going to give you just some numbers. Is European strategic? No, just in 2020, H2020 has a dedicated budget of 35 million dedicated to US space and urban air mobility. It's a research hot topic in the most important conferences in air traffic management. 20 and 25% of the work that has been presented are focusing on this topic. And well, yeah, and forecasts say that in Europe, in 2050, 150,000 people will be employed in this new industry, and it will generate 50 billion per annum. So our solution consists of the next building blocks. So we have developed a sensorized drone that is characterizing atmospheric conditions. It's characterizing visibility, temperature, humidity, winds. This data is sent to a high-performance computing, and while we are providing this real-time information for sure, but we are feeding our models that are hosted in a high-performance computing to develop weather forecast model. And in the last step, we are providing our user this information using some services that I will show you later. Well, so in order to build this product, we need to have a complementary background of the member of the consortium, and I'm going to present you the consortium. So we are Aslogic, we are developer of decision support system for aeronautics. We have TESGA that has been supporting us and providing supercomputer capabilities, and we have University of León. They are expert on meso models, weather meso models based on weather forecast model. So when we are building our report, we are relying on weather research and forecast model. They are numerical weather prediction method that allow us to do some idealized simulation or experimental real-time forecast. Well, I don't want to simplify too much the problem, otherwise my friends for University of León are gonna get mad with me. But you know, just to give you some insight of why we need this high-performance computing capabilities, here you can see, a set of differential equations that we need to solve in order to obtain our weather forecast. They are quite complex, so we are not gonna need a numerical method. And as a former physics student, I know that every time that I have to solve a differential equation numerically, I'm gonna need time, I'm gonna need a super good computer, and I'm gonna need my expertise or the knowledge to know the parameters that I need to play with in order to have a valid solution, right? So, well, this is not basic, real easy, right? It's not easy. You need to give you, and you need some specialized support. And for sure, then the other thing that we need to set is the contour condition that we have, that we are going to have in the airspace volume in which we want to have a solution. And then you have to be careful with the resolution, because for example, with this in this specific project, we were developing a model for a region in the north of Spain that has 30,000 kilometers square, and we want to have a resolution of 3 kilometers horizontal and a different altitude, and the altitude are 10 meters, 20, 50, 100, and 125. So as you can see, we need high performance computing resources. Why? We need it in the first step because we are developing weather for different weather forecast parameterization, and each parameterization has 23 variables to be tuned. So, well, as I said before, you need to play with those parameters in order to get a good model. So imagine how much time will be required if you don't have the computing resources, right? So using high performance computing resources, you can shorten development time from months maybe to weeks or days, right? And then we are gonna run our models in a daily basis in order to give operators this information. And we are, as I have said before, we are providing a weather forecast model for a big volume, 30,000 kilometers squares at different altitudes, as I said before, 10, 20, 50, 100, and 125 meters. So we need to reduce the execution time from tens of hours using a regular computer, right, to minutes. And then as an SME or as a developer of a product, you are going to have certain questions in your mind that are not easy to answer, right? And you are going to need the support. And that's why FEDGA has been so important in this project. So the first thing that you need to ask yourself is how quickly do I need to have a solution? Well, you are developing a service, so you need to carefully know the service that you are selling, right? But then it's super tightly interconnected with the computing resources that you are going to need. What horizontal and vertical resolution do I need? And then you need to translate that to computing resources, right? How many cores do I need? If I use more cores, will I have the result in shorter times? And sometimes this is not true. How large is any data set that you need to load? How much memory do I need to complete a run? So as an SME, at some point, we knew that we need some help. And that's why FEDGA University of León has been key to develop this product. So thanks to FF4, we were able to tune our weather research forecast model. We were using 1,400 core hours in order to tune our models with more than 100 jobs were submitted. Well, and this is thanks to the expertise of University of León, that we didn't need so much jobs in order to have the model parameterized. And then we asked ourselves how many times do we need to provide this information, to update this information. Well, we have a customer that I will explain, I will present later. So we agree with them to use 4 times per day update this information, although it can be done every 10 minutes. But then as an SME, you need to know that your cost will increase because you are going to need to run higher computer performance, right? Then the running time in our model was, for running the 4 models, it was 1 hour, 1 hour and a half. We were using 2 cores hour, and we were generating 10 gigas per execution. So here is the meteor drone, what we call the meteor drone, the drone sensorized, let's say, with all the sensor on board. And you see how it was quite tricky to find the nice location of this sensor in order to avoid any effect of the rotors on the measurement that we were doing. So here we had the temperature and dew point and the wind sonic sensor and data logger. That's why, you know, we have created that column in order to have the sensor isolated here and avoid the rotor effects. So for some months, we were in the north of Spain in this remote pilot aircraft system certification center, flying our drone. But it was a super nice location because as we were in an aerodrome, we have all the complementary ground station just to compare if our measurements they were right or not, right? Well, and what we found, so we found that we have some advantages. We have better wind characterization at low altitudes. So, you know, using an anemometer, we were having quite accurate measurement from 0 to 10 meters, and then using SODAR from 50 to 125. But then this altitude interval in which, well, we were not able to get such a with measurement and with the metadrone, we're able to solve this. So that's quite interesting. So then we spent some months, University of León, characterizing this region from the north of Spain, Galicia. So they did a data harvesting campaign in 4 different locations with more than 120 flights. We developed the weather forecast model for the surface that I previously said, and we obtained quite a nice accuracy of wind prediction in 80% of the volume, while the accuracy was lower than 1 meter per second. And this is the final product that we developed. At the end, we want to support operators while they are planning their mission. So here you see a website in which we offer operators while they are able to plot or to specify the mission, the flight that they want to perform, right? Which model they are using. So then they submit the mission. So we run the model and we provide a specific weather information for them. So here you can see with a color code that is dedicated to the specific model aircraft that they are flying, if the condition that they have, they are good or bad. So if it's green, no problem. It's yellow, well, warning, and then red, you should not fly. As I said before, it depends on the model that we are flying, of aircraft that we are flying. And for sure, well, we provide different variables. For example, the wind direction, that is quite important when you are flying a small aircraft. Well, and a big aircraft too, right? You can have some wind shear effects that can impact the lift of the aircraft. So, well, we have the opportunity to validate our product with the final user. So we involve TR. TR is a remote pilot aircraft system certification center that we have in Galicia, and they are using now the product that we have developed. And for sure, we found some challenges while we are executing the project. So we found that when we have some inversion, temperature inversion in the atmosphere, we need to improve the accuracy that we are having, something that we need to do. And we have also need to improve the communication robustness of our drone. We are studying how to use LoRa or 5G, 4G network, how to do it to improve it. Well, next step, we are wondering if it will be possible to use this service in airport, in regular airport, and provide this live information from aircraft support during approach. As I said before, when we have wind shear, the lift of the airplane can change, and well, we can have hard landing and damage the structure of the airplane. So as national agencies, they are not providing real life information. We are wondering if we would be able to do that. We have taken the first step, but we need to tackle certification issues in order to offer this service, something that we are studying. And then we plan to go from meso weather model to micro weather. In the future, we will be flying on urban environments. So we need to reduce the lateral resolution of our models from kilometers to 10 of meters. We will need to use continuous fluid dynamics or maybe some artificial intelligence algorithm. And that was all from my side. Thank you very much all for your attention.
Okay. Good morning. I am Emanuele Della Volpe. I'm an aerospace engineer, CEO and founder of GreenTech Solution. And I'm presenting the HPC-based navigation system for marine litter hunting project. Is an upgrade of autonomous litter hunter approach through the high-performance computer. GreenTech Solution has developed a unique approach to attack the marine litter problem through an intelligent system, which is composed by an aerial and weather manned vehicles that autonomously identify and collect the floating plastic waste in the sea. The consortium is composed by University of the Study of Naples Partenope, which is a public Italian university with a background in science of navigation, maritime economy, and computer science. Then we have BIREX, the Italian competence center with a specific focus on big data and innovation process with a business perspective. Finally, Cineca for the fundamental computational resource available for the project. GreenTech Solution has automated the collection of marine litter through real-time identification of floating plastic waste via unmanned vehicles. Is a drone and catamaran in a collaborative mode that are able to operate without any intervention of the operator. The drone sent through a ground control station the GPS coordinate, and the boat which reaches this coordinate, it collects the plastic waste. The operation limit is to predict just until 3 or 5 minutes the movement and just the waste movement, and just in calm sea condition. And these conditions force the flying unmanned vehicles to stay close to the waste, it's really not good for the process optimization. In fact, the limited ability to predict the future position of the litter is limiting the efficiency of the entire system, like the time and energy consumption of collection it's increasing significantly. The HPC experiment allows us to overcome this limit through new features like marine litter recognition, marine litter path prediction, and marine litter recovery strategy optimization. These computational approach need more than 250,000 hours of deep learning, which is impossible under conventional computational system, but it's possible thanks to Cineca. And moreover, the HPC, through the HPC, we plan to triple the amount of kilogram of plastic collected. GreenTech Solution has not found a direct competitor and is now the only European company that use collaborative unmanned system to carry out the cleaning operation in sea in a sustainable way. We develop a proprietary solution able to collect marine litter in automatic, more efficient and cleaner way, reducing 60% the cost of the labor respect the indirect competitors. HPC will generate direct benefit for GreenTech Solution. As example, the release of proprietary autonomous navigation software running a cloud. The accuracy result, a higher accuracy result thanks to the computational power, new APRs, new digital platform for marine litter that you can see on www.marinelitter.it. Then we expecting more result in terms of to have capability to identify and classify marine litter in terms of dimension and materials, and not just on the kind of material, the class of the waste. Then we get more accurate prediction of possible trajectory over longer time and wider area. Then we have a real-time tool for navigation optimization and mission planning, and we get reaching 2,000 kilometers of European coastal line in the next 5 or 6 years. We will get. This flowchart summarizes the pipeline of the experiment. So we have the data acquisition and processing of the image and the path dataset. Then we have the training of neural network for object detection and path prediction, and the calculation of recovery strategy optimization. This is the three kind of data that we use in order to get the HPC application. Here, there is a short video showing the release phase of the bottle target, divided by color according to the float level. It's possible to see how after a few minutes the two type of waste tend to separate as a less merged ones and more influenced by the sea current. And as you can see, the two kind of bottle it's going with different path, and this is important information in order to get a good training for the path prediction of the waste, depending on the kind of waste. Perfect. Here, when we catch the bottle. Okay, task one. So regarding the working plan, task one is related for to collecting data for milliliter recognition. So we talk about milliliter image. For milliliter path, we have a lot of path realized using the real bottle or real waste, but we have a lot of milliliter path that are the output of oceanographic simulation. And then we have a laser drift path, which is a special sensorized buoy able to register the geolocalization time path. The task 2 is related with training validation milliliter identification. All the objects of each image acquired are labeled using dedicated software and dividing them into two different classes like bottle, polystyrene, mask, soft plastic, and hard plastic. This neural network allows us to recognize 5 different classes with over 90% of total accuracy. Here I show another short video that show you the result of the neural network for the milliliter recognition, and this is a really good result because it's able to operate in real time, so it's really fast the process for the milliliter identification and geolocalization. Okay. Task 2 is related. It's related with the oceanographic model simulation and validation. The high-resolution Campania regional sigma coordinate ocean model (CROM) is coupled to a Lagrangian particle tracking model to simulate milliliter transport in the Gulf of Naples. 16 simulations were performed, and for each simulation we have 10,000 passive tracer that we released in the area that cover the entire Gulf of Naples. Here you can see an example of how an oceanographic simulation can give us the input data for the neural network able to predict the path, the waste floating path. Task 2, so it's So the simulated marine litter path have been used in order to train the neural network, and here we can see some result about the difference between using neural network respect the real floating path, and we get really good accuracy, considering that in the image are presenting a prediction in a longer several hours of prediction. Task 3 is related to the optimization strategy for the litter recovery. So a multi-objective genetic algorithm has been used. The algorithm is capable of minimizing distance covered and time spent by the unmanned surface vehicle to retrieve the marine litter, to collect the marine litter, while respecting the navigation regulation and vehicle performance limitation. As you probably know, for the sea navigation, we have CORREG 72, which is international regulation for collision, for avoid collision at sea, which is really important to take care about the marine navigation. The business impact and risk analysis task provide us a cost assessment, a price strategies, and an elaborate, more accuracy business model. This task analyzes the economic impact linked with the HPC powered solution in order to how more kilometers of coastal line, how many kilometers coastal line more we can monitoring using the same solution. The advanced business plan elaborated in the HPC project identify several opportunities for this point of view, and we plan to create 25 boat and drones in 3 years. Will allow the company to reach more clients in mid and long term. We plan to have more clients in 3 years. So we plan to use 200,000 marketing expenses in 5 years that allow the company to generate the right awareness, and using the HPC solution, these will produce more 15% of the potential turnover with the autonomous vehicle, and less 14% of maintenance cost. General challenge and next step and were identified in a transversal way. So, for example, we plan to use a new oceanographic model representative of different scale of the phenomenology in order to create a right logic for mixing a large scale model and a small scale model. It's a use that we see in the real operation activities, cause the Gulf of Naples it's served by a wide large-scale model, and we plan to get a more accuracy of the path prediction using more localized and less scale model mixed with the large-scale model. Then we plan to increase the number of object recoverables from the unmanned vehicle, and decrease the sampling of the point of the trajectory predicted by the neural network to 5 minutes. We obtain a local meteorological, a challenge is to obtain a local meteorological data by analysis the drone flight data. These allow us to improve the data set of path prediction, in particular for oceanographic simulation. Then another challenge will be to science the object detection by image, but it's quite reached as a challenge, because using a measurement algorithmic based on acquisition input like height, footprint, sensor footprint resolution, and so on, we can determine the dimension of the floating object, and we can determine the buoyancy level based on the size of the new object and the detection of the emerged part. The challenge will be to have a neural network training for identification a greater number of object classes. In fact, now we can recognize 5 kind of waste floating object, but we plan to go in deep about in order to have more and more number of kind of object to able to identify, and then neural network training for path prediction with a greater number of objects in order to optimization the control of the catamaran based on the meteorological and oceanographical data. Okay, thank you very much for the attention. I'm here for the question.
Okay, good. So then let's start with the presentation. So welcome from my side. So I brought my data scientist colleague with me, our data scientist lead, Marcus, especially for the more technical part, to give you some insights about that. So let's start. We have market innovation sourcing was the name of our project. And what we did shortly, just that you know where we are from. We are PriceIntelligence and PriceIntelligence together. Because of that, Marcus is also here. He's from the PriceIntelligence. I'm from PriceIntelligence. We are the experimental lead at that point, and with the help of PriceIntelligence, the data scientists and the solution architects there, we work together. We also had some other partners, for example, like SICOs and HERCULES and GTS, so HPC providers, and also scientific collaborators through the whole project. And that was the whole consortium and all the roles we had. So, and what was our challenge and why we need HPC? So directly at the beginning, we from PriceIntelligence, we have a look outside of the market, and we analyze market situations, especially pricing. So you heard it already from the names. So we crawl platforms to get to find articles, and then to get the information, how many offers are there, how the articles look like. And especially at the moment, we are searching more on an EAN level. That means we search for an article. If we could find it with the EAN, then we have that one. But what we see is we have an increasing number of international e-commerce platforms outside, and also a big number of data. And what we wanted to do is we want to find also similar articles and competitive products. So the market is getting bigger. We also saw it during Corona that it's really exploding there. And so we wanted to develop a product portfolio also with its on par with other competitors. They also could do it already to find matching articles, not the same what I mentioned, directly one-to-one. It's about the same browser, black one, just from other brands, for example, just to give you a short picture about it. And the idea was at the end also to development of a competitive pricing strategy based on this data. For this big data, it's compared to identify hits matching of products. So which information we have text. When you think about a product, you find a laptop or so on, there's titles, attributes, and descriptions. We have images, and our idea was it, okay, let's have a look on each of them or combine it, and then find the matching product about it. In general, the permanently increasing amount of the MS data, what I mentioned already. running the algorithms and neural networks for the matching HPC power is needed, especially for that part, because it's a big amount of data what we have to handle there and to learn the algorithm. So what was the expected outcome? Just to make it clear, what we wanted to reach at that point, we want to find similar products directly based on the embeddings, also counterfeit products, similar missing particle details, so if there is something, and also an analysis of the product portfolio in an n-dimensional space with significant dimensions at the end. And yes, with the available computer power, we will allow us to verify these meaningful embeddings at the end. So that's why we need it. Yeah, I will directly give to Markus.
Thank you, Martin. So now a bit more into the scientific details. So what are we actually trying here? So first of all, a lot of the matching that we do, it can be done with pre-trained networks. They are readily available, like ResNet 50 exception, now vision transformers, they come, and we can already use them. They take images, they convert them into embeddings. We can do all kinds of mathematical operations. But the problem is that they are not quite business ready. They are trained on different data. Well, they're trained on cars, houses, boats, fish, and so on and so forth. So they are useful. They bring us like 50–60% of the way, but they don't take us quite to the end. And the goal of this project was to go the rest of the way, and that is a very important thing, to use it with as little user interaction as necessary. Why that? Because you can always label data. You can find people, label data to this. Is this a what kind of trousers is this? Is this a shirt? Is this cropped or whatever? But the point is that with the large amount of data that we are dealing with, labeling just takes a quite long time. And so all the approaches that we take, they come from the family of the so-called self-supervised learning methods. So the information you get from the data, they all belong to the same article. It's kind of labeling itself, and we use that information and we try to bring it together. And the first approach that we had was that we have a so-called image-only master product embedding. So we just take the image information, because like in fashion, as we see here, a lot of the information is actually already in the image. So it's not like in consumer electronics where you have a USB pen and they all look alike, whether they have 2 GB, 4 GB, or 128 GB. In fashion, a lot of the information is contained in the images. And so what we try to accomplish here is that when you go to a web page and you see, you browse T-shirts or whatever, then you see that there are different kinds of images, but they all belong to the same product. So there's like a cropped image, nice. You see just a T-shirt on a white background, but you see also a detailed view. You see the T-shirt is worn by a person. And the goal when we want to identify these articles from on different platforms, for instance, is that we can bring them together, because on the different platforms they don't share the same image. They have the same products have different images. And so what we did here was that we basically used these pre-trained networks to give us an intermediate embedding, and that is highlighted in the middle. So you see it in the diagram there. So all the cropped T-shirts, they all go to the bottom left, and then all the persons, they go to the bottom right. And the goal is eventually to just bring all the images together that belong to the same article, and then this is what is seen on the right. So next slide, please. So what was the data that we actually worked with? So eventually we crawled a couple of platforms, and we had more than 200,000 articles and a million images for all of this. And this data set is constantly increasing, and now you might also see why labeling is actually not really an option. And the goal was to just bring all this together and train networks that allow us to bring images that are very dissimilar from their type together and just say, okay, this is actually the same product. Next slide. So for this training, what we did was actually that we used the Siamese network approach. So basically we took two images that were from the same article, but the images were different. And then we trained a new network that just said, okay, these are actually the same. And then we took two images from different products and said, okay, these are not from the same product. And this was repeated, well, for 500,000 image pairs. And so we trained, first of all, we generated these intermediate embeddings for all these images. Then we trained the Siamese networks on the custom layers, and these are the ones that follow after the pre-trained network. We also played around with the pre-trained network itself, that we altered the last couple of layers to get the better result. And all this was well, didn't really work out, so we had to add another layer of well, information, and this is one that we couldn't really avoid. That was this active learning layer. So first I said we don't want to label it, but we realized that there was just a too large a mix of different images, that we had to get an information whether an image was a cropped one, an image was with a person, if it was a detailed view. And on the road, we then developed an active learning framework for us that allowed us to label tens of thousands of images within like half an hour or so into a cropped one. Does it show a person, yes or no? Next slide. So eventually this then led to billion image pairs that we then compared and then just tried to find the match in the other set of data. In total, we had 33 million article pairs, so article compared to article, and we tried to find the matches. Eventually, that didn't really work out, and the reason for this is that our algorithm was not good enough to just distinguish the shirts that had a little decal here on the side with other shirts that had the decal on the other side, or these kind of little details we couldn't really identify. And so for finding the exact product, this network eventually wasn't good enough. So for that, you have to add other things. We had plenty of ideas, but we actually had to move on in this. And so from this first approach, what we actually took was a lot of knowledge in what are the details we have to look at, and second, the active learning as a tool that we now readily use in other projects. Next slide. Yeah, so in the second approach, we then used multimodal networks. So rather than finding identical products, we were looking for similar products, because that is kind of easier, because then we don't have this problem, where's the decal, because in the end we're looking for white t-shirts. And so this is the combining text and the images. And as a first step, we took all the images from a product and we merged them together into a so-called multi-image embedding, so that we have a kind of a representative embedding for the product. And then we combine that with the text information. And this is done through the so-called cross-modal deep clustering, that we have two streams of, well, first image data and text data. We then classify it. Then we exchange the labels of the clustering. We exchange the labels so that the one stream has to learn the labels from the other stream. And through that, there's an exchange of information, and you kind of iterate it for a couple of times. And next slide. And so this was done with a hyperparameter search. This took us roughly 2 to 3 weeks to just go through the grid But eventually we found that there was not enough overlap of information. So what we think is that the information in the text is too sparse. So there's a long description, very prosaic, describing the greatness of this article. But the relevant information is just this little sentence, and we just didn't manage to extract that one. But this multi-image embedding that was generated as this first step, as a standalone solution, that showed actually superior performance compared to the original embeddings, the raw pre-trained embeddings. And this is now actually the one that is used in production. So we have a service that allows us to just query articles for the most similar articles, and this is the one that actually we use in our service. Yeah. And with that, I hand back to Martin.
Thank you. Yeah, shortly to the benefits of this project. For us, it was the first time of implementation of such a project. So we never did it before, and we never started something like that about AI, machine learning topics or so on. So we built a new team for it, and also for our customers was a new thing, completely new. So it was, to be honest, not possible without this project and experiment what we could do here. Besides trends and competitor and counterfeit identification, we also saw that the identification of similar spare parts to support mechanical engineering. So in a B2B area at the end, that's something we saw on the way. That's also really interesting to find similar products, because we get some requests, especially when you think about supply chains at the moment, and they are broken for some companies, and they want to find now some similar parts for their machines, and so that they can go forward with their production. And that's also an interesting thing what we saw during the time. In general, we had a big know-how gain in both companies because of this project and experience. And you already hit it, what we tried and what we, how many experience we had inside of this global experiment for us. And now the result is at the end that we have new business models and products available, and which already had led to sales in the range of 70,000, and it will be more because we already discussed with some of our customers they're really interested in, and now we want to define some future projects with them, how we can go forward, and what we can do there. So we can also acquire new customers. So from our perspective, we increase 30% increase in sales. And that's really good news for us, especially in the current market situation. And then also what was interesting for us, because you already heard it, PriceIntelligence and ParseInate. Yes, we are PriceIntelligence part of the ParseInate, but it was first time also that we had a cross-company team working together, and with the distributed know-how and bring them together and work together on such a solution. And that was also one of our main benefits here. Besides also what is not standing here, we hired also already some people, and it will go forward with this project. So it will not stop right now. We're already working on, we call it matching 2.0, and it will go forward. And that's also the idea to hire additional employees to bring the results to our customers. What is learning? Just also to give you some insights from our side. You saw it already. We had some troubles beginning to find something, and it was not mentioned in the whole presentation, but we experimented so many that we had forgot to focus on our customers' needs. And we find it back, and we come back, and we have now a result what the customers' needs is there. That's just something I wanted to mention to you. That's really important, that you need to focus at the end on the customer side also on what they need and how they can use the results you will produce and the product. Then set up a stable team for this project. It's a long project, and if you want to go or if you want to see progress through the whole time, you need a stable team. We had to challenge that PO left us already after 2 months, and that also the staff team member was not available. It hit us a bit during the project. That's something you should be aware. So if you want to get good results, you need a stable team to come forward. And Marcus already mentioned it, try and error. helps a lot to improve your product and your results. And I think that's a really, really good one. That we had this experience and that we had this time and that we could do that, especially, and also that we got the resources from the HPC to try several things, and now we have a great result. Yes, thank you from my side.